Hi guys, today we are on our second topic of our trigonometry booklet and we are looking at angles of elevation and depression. Before we begin and talk about elevation and depression, we first need to know about complementary angles, which are angles that add up to 90 degrees. In this triangle here, if one of the angles is already 90 degrees, we know the whole angle sum of the triangle adds up to 180 degrees. So the remaining two angles must be complementary because 36 plus 53 add up to 90, and then all of the angles in this triangle adds up to 180. On the flip side, if we do have a right angle and we draw a line that splits it, we know if one side's 40, the other one has to be 50 because they are complementary angles, and this angle is 90 degrees. 40 plus 50 also equals 90 degrees. Now, this lesson we're looking at elevation and depression, and the easiest way to find elevation and depression is by first drawing our horizontal line. So, angle of elevation is generally when we are elevating and going up, whilst our angle of depression is when we are decreasing and going down. And the thing about our angle of elevation and depression is, keeping in the theme of this topic, normally we can draw a dotted line and a right angle to actually realize that we're going to just go back to SOHCAHTOA in solving for unknown distances or angles. So the angle of elevation is equal to the angle of depression, and this is called an alternate angle. So if you remember your lines when you've got parallel lines, alternate means every second one. So this angle is equal to this angle just because of how they fit on parallel lines. Okay, now we're going to start our first question, which talks about a park ranger measuring the top of a plume of volcanic ash. Alright, so if you want to, you can kind of draw this little bit here just to make it more like what it's describing. So the park ranger is on this side here, and we know that they're 7 kilometers away from the volcano, and there's an angle of elevation of 41 degrees. So what we can see is effectively we have a right angled triangle. So what we like to do with our right angled triangles is SOHCAHTOA. What this will mean is we need to label the sides. So this one's the opposite here, this one's the adjacent here, this one's our hypotenuse here. We'll notice we kind of just care about the opposite and adjacent, so we are going to be using the tan ratio. What I'm going to write below is tan theta equals opposite over adjacent. Now what we can start to do is fill in some of these numbers. We know that our angle is 41 degrees. We know that our opposite is just unknown, so I'm going to call that O. And our adjacent is the distance 7 kilometers. And what we can do is solve this equation by timesing both sides by 7 and ending up with 7 tan 41 equals to O. What I'm going to do is now type that into my calculator. I'm going to write 7 tan 41, right? I normally close the brackets, but you don't have to, you'll get the same answer. And our answer is 6.08500, but because we want it to 2 decimal places, we are just going to write 6.09 kilometers. So that's how we would solve this first problem. The next problem we deal with is one without a diagram, but we know with these diagram questions we can quite easily just add one in. So we're reading the top of a cliff is 85 meters above sea level. Min saw a tall ship. He estimated the angle of depression to be 17. So assuming we've got the cliff here where Min is standing on, we've got our little boat Okay, this looks like a car. All right, out here. And this time we're talking about the angle of depression. So we're going to draw our horizontal line in and just write 17 degrees there. So what we want to find out is how far the ship is from the base of the cliff, and we want to answer to the nearest meter. We also want to find out how far the ship is in a straight line from the top of the cliff. So this line here. Now, before we tackle this second question, all right, I just want to show you that we can actually solve question A in two different ways whilst getting the same answer. Okay, so what we know is with question A, we could theoretically draw a triangle like this. So over here is the height, 85. Over here is 17 degrees. And we want to find how far the ship is from the base of the cliff. But if we look at the line we draw down here, that's kind of the same as the line we draw up here. So if we find out what x is, we could easily use this triangle to solve our problem. I'm just going to quickly label the other sides. This is the opposite, this is the adjacent. So this time we'll be using TOA again. So tan 17 equals 85 over x. Now if you remember from last lesson, if you have a letter on the bottom and a bunch of numbers on the other side, what we can do is just swap them and end up with 85 over tan 17 as a little bit of a shortcut. Otherwise, you can times both sides by x, divide both sides by tan 17, and then you'll still get the same line of working. So again, we're going to type this in our calculator, 85 over tan 17, 85 over tan 17, and remember to close the brackets. And then we end up with this distance, 278.02. If we want to answer to the nearest meter, that will just mean that it's 278. Now, the thing about earlier this lesson is that we talked about complementary angles. And here, we know that this is just a 90 degrees because we assume this cliff is just a straight drop. This is our horizontal line. So what we can actually do is find out the angle that's at this point. How we do that is by just doing 90 minus 17. That gives us an angle of 73. And what we then can do is draw a triangle that looks like this instead. Write x down here, write 85 like that. And we're going to put the angle 73 in there. Now, with our trig ratios, we would effectively do the same thing. Okay? So what we're going to do is we're going to label the sides now. And what you'll notice is that the opposite and the adjacent have actually now swapped. Alright? In our previous example, the opposite was the distance, our opposite was 85, our unknown distance was our adjacent, but now we now know that the opposite is our unknown and our adjacent is actually 85. This makes it a little bit easier when we're substituting into our tan formula. So tan is opposite over adjacent. And then you're like, hang on, to solve this, I just need times 85 by both sides. And then when we type 85 tan 73 in our calculator, we actually get the exact same answer, x equals 278. So there's actually two different ways to solve this same problem, and it doesn't really matter which way you solve it with, as long as you make sure you're using the right trig ratio. You'll notice we're using tan both here. Sometimes when you use cos with one and you can use sine with the other, right? And that's actually what's going to happen with example B. So with example B, what we're going to do is I'm going to do the two methods again just to show you, but on the YouTube link I will tell you when the next question is. So if you're happy with this and you've already started to work ahead, you can kind of just keep going on with that. So what we're doing is we're drawing the same triangle here. We've got our same angle, 1785. We know this distance here is now 278, but I'm not going to actually add that in there right now, just because it's not going to be as helpful to find the straight line distance from the ship to the top of the cliff, which is this distance here. Okay, so now we've just got the same thing. We've got an angle, we've got a side, we've got this side here. So again, I'm going to label them. That's my opposite, this is my adjacent, and that's my angle there. Which one uses, whoops, that's not adjacent. That's my hypotenuse. So I've got my opposite and the hypotenuse. We know that SOH uses that. So sine 17 equals 85 over h. Okay, and then what I'm going to do is I'm going to swap these again. H equals 85 over sine 17. And when we type that in our calculator, and this time I'm going to remember to close the brackets, we end up with our distance of 290.72. Again, answering to the nearest meter, that's 291 meters. So we're going to do this with our second diagram, and this time we're going to be using the cosine rule. All right. So if we label everything on this triangle, we'll notice we've got the adjacent and the hypotenuse. That means this time we're using cos 73 equals 85 over h. We do the same trick where we swap the h and the cos 73. And then if we type that into our calculator, we end up with 291 as well, which shows us that there's two different methods to get the same answer. So what we are going to move on to next and lastly is this last example of a lighthouse on a cliff. Now, with this example, it's a little bit of a tricky example, but really what we're doing is finding the difference of the two heights and using that difference to find the height of the lighthouse. If we worked out the total lighthouse plus cliff and we subtracted the cliff, then all we'll be left is with that lighthouse distance. Okay? Now, what we need to do is we are looking at our diagrams and drawing two right-angled triangles, one slightly taller than the other. We know that our elevations is 42 degrees and 50, so we're going to draw the smaller one 42 and the larger one 50. Right? If we have a bigger angle, that means we're going to go higher, and that's why our bigger triangle is our bigger angle. And the thing is, we know the distance from the cliff is actually the same. But we know that this distance is just the cliff, and this distance is the cliff plus the lighthouse. Now, what you might want to do is, instead of having two letters here, just like call it H or something like that, just for the height, and then subtract them after. But the reason I've labeled them as C plus L is because we know that this is the cliff and the lighthouse, and we know that this is just the cliff. So, with this diagram here, we are going to label our sides. We've got the opposite side there. We've got the adjacent side here. We've got our hypotenuse over there. And likewise, we've got the opposite here. We've got the adjacent here and the hypotenuse over there. Now, all we need to do is solve for C and C plus L. So what we're going to do is we are going to write out our trig ratios. We're using the opposite and the adjacent. So this time we've got tan theta equals C on 75. And then we also know the angle is 42. So tan 42 equals C on 75. That's not necessary. Then we realize that multiply the 75 over, we can get C by itself, and when we type that into our calculator, we end up with 75 times tan 42, which is 67.53. We're going to do the exact same with the other triangle. So tan 50 equals C plus L on 75. And we're going to solve this. So 75 times tan 50 equals 89.38. And so the difference between these heights is going to be our final answer. So our lighthouse is actually 22 meters tall.